Hello students, in previous session we have studied the distributed consensus. Then we have also studied how the proof of work mechanism works. Then in this session we have to study the proof of work mechanism for Bitcoin network. Then we have to study the hash cash and monopoly problem. Monopoly problem in the uh, proof of work, and what is the solution to the monopoly problem that we have to study in this session. So students, in previous session we have studied how the proof of work mechanism works. Proof of work is called a distributed consensus. In Bitcoin network or in blockchain network, we know that every miner has to agree on the state of the machine, and for agreement on the state, the nodes or miner use the consensus mechanism. And for consensus mechanism, different algorithms are used. So this proof of work algorithm is derived. This concept is devised from the concept of hash cash. So we will learn what is hash cash, how this hash cash is used as a proof of work mechanism in Bitcoin network, that we will try to understand in this session. So proof of work is the original consensus algorithm in a blockchain network. In this proof of work, miners has to solve the puzzle, and miners will solve the mathematical puzzle. Miners will form the new block from the transactions. Miners will receive the transactions. Miners will bundle these transactions into the block. They will put the transactions into the block. Block is created, and if the miner is lucky, if the miner is able to solve the mathematical puzzle, then miner will propose a block in the Bitcoin network that we have studied in the previous sessions. So how complex a puzzle depends on the number of users, the current power, and network load. So we know the concept that every node in the Bitcoin network has to take 10 minutes 10 minutes time for solving the mathematical puzzle and for proposing a block in the network. So if the number of users are less, then mathematical puzzle is more complex, and if the number of users are more, then complexity of this puzzle may get reduced. So the accurate work and speed of the blockchain depends on this proof of work mechanism. So if the problem cannot be solved in a definite time frame, if the mathematical puzzle cannot be solved in a definite time frame, then block generation will become a miracle. Block generation will be a kind of miracle, because if this puzzle is very complex, and if indefinite time is required to solve the puzzle, then the block generation and addition of the block in the blockchain will become a miracle. But if the problem is too easy, if this mathematical puzzle is too easy, then it is prone to the vulnerabilities and denial of service attacks and spammers. Spammers can easily solve this mathematical puzzle, and spammers can take the control of the system. Spammers, or we can say malicious nodes, can insert the block in the system. So this complexity of the puzzle depends on the number of users, current power, and network node. So in previous session we have seen this diagram. We have studied how the proof of work mechanism is implemented. So there is a network server. Network server is the has the main role. The network server gives the puzzle to the miners, and network server controls the complexity of the puzzle depending on the network load. So this network server will send a puzzle to the miners. Miners are nothing but nodes that try to solve the mathematical puzzle, and miners has to spend resources. Miners has to spend the energy. Miner has to spend the computational power to solve mathematical puzzles. The miner's computer, miner's hardware should be fast enough to solve this mathematical puzzle. So it is not possible for any general purpose computer, any desktop PC to solve this puzzle. So for solving a puzzle, a powerful computer is required, and miners has such kind of powerful hardware. And in this figure you can see there are three miners. Miners are these three miners have proposed a solution. Solution for the puzzle. Miner 1 will propose x1, miner 2 will propose the x2, and miner 3 will propose the x3 solution. And these miners will send the solution to the network server. Then network server will check the solution whether the solutions are correct or not. So in this figure, the miner 2 has proposed solution x2, and that solution is correct. That means this miner will get the reward. This miner is able to propose a ball. This miner is able to propose a block in the Bitcoin network, and for proposing a block, the miner will get the reward, or we can say incentive. So this is how this proof of work mechanism works, and that we have studied in the previous sessions also. This proof of work concept, this proof of work mechanism is derived from the hash cache. Hash cache is the origin of this proof of work mechanism. So we will try to understand the concept of hash cache. Hash cache is before the this consensus algorithm, and the concept of hash cache. Concept of hash cache is used in the proof of work system. Hash cache is a proof of work system. This hash cache is a proof of work system used to limit the email spam and denial of service attacks, and more recently has become popular for its use in Bitcoin. So this hash cache is used for emails. This is used to prevent the spammers from sending the emails. So for restricting the spammers in email system, hash cache mechanism is used, and this hash cache is now used in Bitcoin, and because of Bitcoin, this hash cache mechanism of proof of work become popular. So hash cache is a cryptographic hash-based proof of work algorithm. This algorithm, hash cache algorithm, is based on cryptographic hash-based proof of work algorithm that requires a selectable amount of work to compute, but the proof cannot be proof can be verified efficiently. So this hash cache requires a amount of work, amount of computation power to generate the hash key. Yeah, it requires a lot of computation power to generate this hash, and these hash values generated by this hash cache mechanism can be verified efficiently. But for generating this value, hash cache, the computer must be a powerful computer, and the computer must have to spend lots of resources, and if the computer is powerful, that computer only can spend such kind of resources. And if you know, the spammers are trying to send the bulk messages, bulk emails, and for spammers it becomes difficult to have such kind of computational power, because for sending each email, spammer has to spend lot of computational power. So it is not possible for spammer to spend such type of lot of computational power and also time. So this hash cache was proposed in 1997 by Adam Back, and described this hash cache is described more formally in paper. That paper published in 2002. The Adam Back has published the paper in 2002. The name of paper was Hash Cache, a denial of service countermeasure. So this hashcash prevents the denial of service attack in the email servers. So hashcash for email users. A textual encoding of hashcash stamp is added to the header of an email to prove the sender has extended the modest amount of CPU time, calculating the stamp prior to sending the email. So students try to understand this concept. So for email users, uh, uh, in header of an email, this hashcash this code is inserted, and this code is added to the header of the email. That code is called hashstamp, and for calculating the hashstamp, the sender has to spend a lots of CPU time, modest amount of CPU time, and the it is not possible for spammers to spend such kind of uh, 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 computational power for generating this hashcash. So this hashcash can prevent the denial of service attacks on emails. So in other words, we can say as the sender has taken a certain amount of time. So this hashcash gives the guarantee. Hashcash gives the guarantee that sender has spent a certain amount of time to generate the stamp, and this stamp is added to the header of the email, and the receiver gets the guarantee that the sender has spent a certain amount of time to generate this stamp and to send the email. So it is unlikely that there are a spammer. So there is not a chance of spammer has to spend lot of computational resources to send this email message, because spammer sends a bulk messages, and for spammer it will become a difficult to spend such type of computational power on every email. So this hashcash is used to prevent denial of service attack. So denial of service attack, we know that by making the fraudulent attacks, the network may be flooded. So by sending the number of emails, your inbox may get full. So such type of denial of service attack can happen on your email address. So to prevent this denial of service attack, this hashcash is originally used for uh, emails for avoiding the denial of service attacks on the email. So the receiver can at negligible computational cost. The receiver can verify this hash stamp easily. It has to spend the little computational power to verify the hash in the emails. So when the receiver will receive the email, receiver will check the hash cache, or you can say hash stamp added in the header of the email, and if that stamp is valid, that gives the guarantee that the sender has spent modest amount of time for sending the email. So this is the guarantee this hashcash gives. This hashcash gives a guarantee in simple or single line. I can say this hashcash gives the guarantee that the sender has spent a sufficient time, modest time for calculating the hash stamp, and this email is not from the spammer. So this is the guarantee that hashcash gives. So we will try to understand the hashcash at receiver side, how the receiver will create a hash stamp. So for creating the hash stamp, the sender prepares a header. The sender of the email prepares a header and appends a counter value initialized to a random number. The sender will prepare a header and it will append a counter value. This is the random number, and it then computes a 160-bit SHA-1 hash of the header. It will calculate the 160-bit SHA. This SHA-1 algorithm is for calculating the hash value, 160 bit hash value. And if the first 20 bits of the hash are all zeros, if the first 20 bits of try to read this sentence again. If the first 20 bits of the hash, first 20 bits means for each 4 bits there is a one hexadecimal digit. So if 5 most significant hexadecimal digits of the hash, if the 5 MSB 5 MSB x digits, or either we can say if the first 20 bits of the hash are all zeros, if the first 20 bits are of the hash are zeros, then this is an acceptable error. This is an if there are no 20 zeros, yeah, if the first 20 bits are not zero, then the sender increments the counter. Sender will increment the counter. It will calculate the hash value again, and this process will continue and until the sender will get the value, the hash value that has the first 20 bits zero. So out of 2160 possible hash values, there are 2140 hash values that satisfies this criteria, and it is difficult for normal desktop. It is difficult for normal desktop to generate the hash cache, this hash stamp. It requires significant computational power. So for normal desktop machine, for normal laptop, it is difficult to calculate this hash stamp, because this requires a significant amount of computational power. So normal desktop, normal machine, or normal node don't have this significant computational power. So normal desktop cannot calculate this hash stamp. So this is very simple mechanism. It calculates a 160 bit one hash, and the first 20 bits of the hash will be 0. If that first 20 bits are not 0, then it will increment the random counter, and it will again calculate the hash value. So this process is repeated. This process is repeated until the receiver will get the value, hash value, in such a way that in that hash value first 20 bits are 0. If the first 20 bits are 0, then that hash cache, or you can say hash stamp, is acceptable. So then at sender side, this is that we have studied at the sender side. When the sender will try to send a mail, first it will create the header, then it will take a random value, and from that it will calculate a 160 bit hash value. Sender will calculate the 160 bit hash value, and the first 20 bits of that hash value should be 0. Then what will happen at receiver side? Receiver has to check whether the first 20 bits of the hash value are 0 or not. So when the receiver will receive the email, receiver will first check the header of the email. The recipient or receiver computer calculates the 160 bit SHA-1 hash of the entire string, and if the first 20 bits are not 0, if the first 20 bits of the hash value, if the first 20 bits of the hash stamp are not 0, that means the hash is invalid. So the recipient's computer checks the date of the header. If it is not within the 2 days of the current date, then also that email is invalid. Recipient's computer checks whether the email address in the hash cache string matches any of the valid email addresses registered by the recipient. So whatever the registered email addresses are there in the receiver's inbox, receiver will check whether the sender's address is not there in the address book or not. If match is not found, then hash string is invalid. So the recipient's computer inserts the hash string into a database, and if the string is already in the database, that means that this hash cache or hash stamp is invalid. So this is the hash cache, how this is used to avoid the denial of circuit, denial of service attack on the email. So this is basically used for denial of service, for preventing DOS attack on the email. So after successful use of this hash cache for avoiding the denial of service attack on the email, this hash cache is used. This hash cache become a foundation. This hash cache become a foundation for the proof of work mechanism in the Bitcoin network, and this hash cache become popular because of the because of its use in the Bitcoin network as a proof of work. This is the origin of proof of work. The origin is from this hash cache. So we will try to understand the proof of work concept in the Bitcoin network. So uh, for calculating the hash cache, the sender has to spend a lot of computational power. So the time needed to compute such a collision is exponential with the number of 0 bits, and so 0 bits can be added. Uh, uh, adding the 0 bits in the hash time, it is very expensive task for spammer to generate the valid header. So this hash cache prevents a denial of service attacks in the on the email. So confirming that header is valid. So verifying that the header is valid or invalid is much faster. For generating the hash cache, the sender has to spend a significant amount of computational power, but verification is not much difficult. Verification for time required for verification is not much. It is very small time and it requires less computational power. So confirming that the header is valid is much faster and always takes the same amount of time. So what is the application of this hash cache in Bitcoin mining? So as I said, this hash cache become a foundation. The hash cache become a origin for the proof of work mechanism in the Bitcoin or blockchain technology. So we know the task of Bitcoin miner. Miner has to collect the transactions, miner has to verify the transaction, and then miners will create a block, and miners will try to solve the mathematical puzzle. That means miners will try to solve the this mathematical puzzle. For solving the mathematical puzzles, miners has to calculate the hash value. So in hash cache, single hash function is used, SHA-1, but in Bitcoin mining the hash value is calculated twice. Two hash functions are used for calculating this is the difference between the hash cache and proof of work. In proof of work, the SHA functions, the hash functions are used twice for calculating the hash value. So a Bitcoin miner runs a computer program. Bitcoin miner is a computer program that collects, this program will collect a unconfirmed transactions, the transactions that are not confirmed from the coin dealers. Coin dealers are nothing but the miners. It will collect the transactions from the Bitcoin network. It will create a block and it will try to propose a block, and a block is accepted by the network when only when the miner discovers uh, uh, by trial and error a nonce number, that when included in the block yields a hash with a sufficient number of leading zeros. So in this Bitcoin mining, the hash this proof of work algorithm, it will also calculate a hash value of 32 bit, and there must be a first 32 bits 0. As we know that in hash cache, first 20 bits are if the first 20 bits are 0, then that hash stamp is valid. In hash cache uses a SHA-1 hash function and requires the first 20 bits, the first 20 bits of 160 hash bits to be 0. And in Bitcoin's proof of work, It uses two successive SHA-256 hashes. It uses this hash SHA-256 hash function twice. It uses two successive SHA-256 hashes, and originally required at least the first 32 bits. First 32 bits for the hash value must be 0 in the Bitcoin network. So far, this is the difference between the Hashcash and Bitcoin proof of work. In Hashcash, only one hash function is used. The first 20 bits of the hash value should be 0. In Bitcoin mining, in Bitcoin proof of work, hash function is used twice, and first 32 bits. First 32 bits of the hash value should be 0. So this is the uh, uh, difference between the proof of work mechanism in the Bitcoin network and proof of work mechanism for Hashcash. So however, the Bitcoin periodically resets the difficulty level. So in Bitcoin network, to adjust the time, we know that every block should be mined, every block should be created, at least 10 minutes should be required to create a block. This is the rule for Bitcoin mining. And in Bitcoin mining, the difficulty level is adjusted in such a way that this time will remain fixed. So it may vary the difficulty level. It may the network server may increase the difficulty level or may decrease the difficulty level depending on the load, depending on the load on the network. So this difficulty level is adjusted in the Bitcoin network. So the Bitcoin network periodically resets the difficulty level. The periodically it varies. It periodically varies the difficulty level to keep the average rate of block creation at 6 per hour. So 6 per hour means 6 blocks are created per hour. That means for every block 10 minutes are required. In 1 hour 6 blocks, that means one block takes 10 minutes. One for creating a one block 10 minutes are required in the Bitcoin network. So proof of work students, we have studied the proof of work mechanism. Proof of work mechanism in the session 20 also, how the hash value is calculated in the Bitcoin network. So in Bitcoin network, the equation that is used to calculate the proof of work is shown in the figure. Hash value is calculated from nonce, then hash of the previous transaction, and the transactions that that are included in this block, the block that I just recently created. In that block, the transactions are kept, and from these transactions and hash of the previous block and nonce value, this hash value is calculated, and this hash value should be less than the difficulty target. If this value is not less than difficulty target, it will vary the nonce. It will change the nonce. So in this equation, n is the nonce, p cache is the hash of the previous cache block, and tx represents the transaction in the block, and target is the target network difficulty value. So this target value is adjusted by the network server to keep the time of block creation 10 minutes. This means that the hash of previously mentioned block, the hash of the previously mentioned block is concatenated with the transactions and nonce. And the one way to find this nonce is the brute force method. So we have to try different nonce value so that we will this the miner will get the value of the hash less than the difficulty target. And if that value is less than difficulty target, that means the miner has solved this puzzle, and miner can propose a block in the Bitcoin network. Once the miner will solve the mathematical puzzle, miner will broadcast a block, and for broadcasting a block, the miner will get the reward. So this is the concept of Hashcash, how origin of Hashcash, and how the concept of proof of work is taken from the Hashcash. The origin for this proof of work is Hashcash. Hashcash is originally for preventing the denial of service attack on email, and this concept of Hashcash is used as a proof of work in the Bitcoin network, and the Hashcash become popular. The concept of Hashcash become popular because of the proof of as because it is used as a proof of work mechanism in the Bitcoin network. So students, in this session we have planned to study the monopoly problem. We will explain this monopoly problem in the next session. You may get overloaded. I want to spend more and more time on this proof of work, consensus mechanism, mining algorithms, how the miner works, because miners, this Bitcoin network is a network of miners, and miners do the every job, whatever job is possible in Bitcoin network, that job is done by the miner is the nothing but the node in the Bitcoin. So it is a full node. This node has the capacity to do every function means verification of transaction, validation of transaction, proposing a block, calculating the hash value, comparing this hash value with the difficulty target, and this miners will try to solve the mathematical puzzle. If these miners are able to solve the mathematical puzzle, then miners will get the reward. In this session we have planned to learn the monopoly problem, how this miners can create a monopoly problem in the, because miners has the full rights, and the full nodes can create a monopoly problem in the Bitcoin network. So what is this monopoly problem, how this monopoly problem can be avoided, that we will learn in the next session. So disadvantages of proof of work. As we know that for solving a proof of work puzzle, for solving a mathematical puzzle, the miner has to spend a lot of computational power, and for spending the for solving the mathematical power, the miner's computer should be fast. And it requires huge expenditures. Mining requires highly specialized computers. For mining, highly specialized computers are required. General purpose machine, a laptop, such type of general machines cannot solve this mathematical puzzle. It requires a very faster computer. So these specialized machines consume large amount of power. These specialized supercomputers, that are the computers that are very powerful, consume a lot of energy to run this mining algorithm, and that increases the cost, and it also consumes energy. So large cost threatens the centralization of the system. And because when some stakeholders, some peoples that can buy such kind of costly computers, and this will threaten the centralization of the system, since every user is not capable of buying and using such kind of expensive hardware. So this will create a monopoly problem. Then next disadvantage of proof of work is that miners do a lot of work. Miners do a lot of work to generate the blocks, and for this work, a lot of power, a lot of energy is consumed. Then monopoly problem, what is the monopoly problem, that we will discuss in the next session. These miners are capable of doing everything, and these miners will become monopolist in the Bitcoin networks. And these miners, the attack, 51% attack on the proof of work is due to this monopoly problem, as the a 51% attack or majority attack is a case when a group of users, group of miners that are capable, that has very high computational power, that group of computers can control the overall system, that can control the majority of mining power, and this will create a monopoly problem in the Bitcoin network. So we will talk more about this monopoly problem in the next session. Students, in this session we will stop here. Thanks for listening this session. In this session, we have studied Hashcash, how the proof of work concept is taken from the Hashcash, and then what are the problems associated with the proof of work, and what are the solutions for the monopoly problems that we will discuss in the next session. So students, we will stop here. We are spending more time, and intentionally I am spending more time because this is the core concept of Bitcoin and blockchain technology: mining, proof of work, consensus mechanism. So when you fully, I am trying my best efforts that you will understand this concepts of this consensus mechanism, and how the blocks are proposed, how the blocks are verified, how the blocks are validated in the Bitcoin network. So this is the core concept of any Bitcoin or blockchain network. So I will again spend some few sessions, 2 or 3 sessions in this consensus mechanism as per the syllabus. In unit second, we have to study different consensus algorithm: proof of work, then proof of stake, proof of elapse time, what is monopoly problem, and other consensus algorithm also we have to study. And after that, this second unit will get completed. So and thanks for listening session. You try to refer the other sources are available on the internet also. You can go on the internet and you can search what is proof of work. You will get the different YouTube videos, then different material on the internet. You try to read every thing that is possible to you, and try to understand the concept of this Bitcoin network and blockchain technology. So thanks for listening session. Goodbye.